because in class then we will waste a lot of time. Okay, so you do it in week 2. The topic is Trigo MCQ. Okay, Trigo MCQ. Then the participation basically is marking attendance and see how whether respond or not, or you ask question or not. And then the last thing is a tutorial. So I have altogether tutorials 5%, and then there's a project also 5%. Statistic project. So you find that okay, there is no tutorial for topic 4, right? Tutorial 4 missing, right? Tutorial 4 missing. Why is it missing? Because it's replaced by a project now. Okay. So project is actually the for tutorial 4 one, okay? And then at the moment, okay, so I'm not sure how the MST whether will still on or not. Usually there is MST, but in case there's no MST and no exam for this semester, must take this very seriously. The project assignment tutorial quiz, all right? These are very serious because in case we don't have exam, we don't have MST, then we will use this to calculate your final mark. Okay, your affect your final mark. Okay, so this is a very important information. So I must well have to use so that you know, all right, this is important. So I have to you now. So you know that week 2, by week 2 you are going to do the Trigo MCQ, right? 5 MCQ. Okay, all the MCQ have 5 questions. Okay, so I'll do a quick revision for right angle triangle first. Okay, if you find me too fast, then you try to slow me down and complain somewhere. Okay, what is, I think I'm too fast already. Okay, so what you have seen is a right angle triangle. So right angle triangle, so you know where is right angle, and then there's angle here. So this angle is called theta, which I will show you with theta here. Now, triangle has 3 sides. The side opposite the angle is called opposite. Okay, just a name, opposite there, opposite angle, opposite there. The side next to the angle is called adjacent. Okay, and the longer side is R there, is called the hypotenuse. And this is just a name. You know, the triangle has 3 sides, especially right angle triangle. Now, let me say something about the y and x are, because the r is always positive. So then right here first, the r is always positive. Okay, depending on how you draw a triangle, sometimes your triangle will be below. So y is positive. Right? If you draw it upwards, okay. If negative y here, suppose y is somewhere here, then your y is negative now. Depending on how you draw a triangle. So y can be positive or negative, depending on where is the y. So above the x-axis, y is positive. Okay, above x-axis. Okay, similarly, your x can be positive, right? So x is positive if x is on the right. Okay, just like above there, x on the right, so x positive. So after we identify the x already, some of the major Trigo function here, just right here, you can see for yourself. If I want to look at sine theta, sine of theta is opposite y over the hypotenuse. I use color so you can know, okay, this is how you find sine theta. So sine theta can be negative, positive, all right? Then how to find cosine theta then? Cosine theta is x over r. Now x is a green color one. So I use a green color to show you. This is a green color one. And then the tangent theta is y over x. So y over x is actually y is yellow. Then x is green. Okay, this is how people define sine theta, cosine theta, tangent theta for a right angle triangle. There must be an 90 degree there, and then you can use this. Then there are three other angles. Trigo function, one of them is cosecant theta. Okay, cosecant theta is 1 over sine theta. So it just take a sine theta, turn upside down, right? And then secant theta is 1 over cosine theta. So cosine theta you take upside down again, the secant theta, and then cotangent theta is x over y. Okay, it's actually reciprocal of tangent theta. So three major one, and then three not so often used but also important. Just different way to express them. So this slide. Of course, maybe you don't see this in your notes at the moment because I'll show you later on where you can find this note here. Okay, then I think I'm going to have some also other how to figure out the Trigo thing. So in the Trigo, the angle is divided into 4 quadrants. So 4 quadrants. Okay, so this one is the first quadrant. Okay, on the right side, where x greater than 0, y greater than 0. So at this point, all the x are positive, y are positive, where r is always positive. And then this is called second quadrant now. The green one, second quadrant. And then on the third one, this is the quadrant. And then fourth one, okay, here. So the angle is divided into 4 quadrants for Trigo. So how do you tell whether sine positive, cosine positive, tangent positive? So inside there, they give you the information. But a very quick way to remember this is all Trigo functions are positive in the first quadrant. So happen if angle is in the first quadrant, all Trigo, so sine, cosine, tangent, they're all positive. Okay. On the other hand, second quadrant, you only sine positive. Okay, only sine positive. Cosine will negative, tangent will be negative, only sine positive. And then in the third quadrant, only tangent is positive. And then if the fourth quadrant, only cosine positive, then sine negative, tangent negative, right? So this is how. Okay. So a simple way to remember this: all A for all, S for sine, T for tangent, C for cosine, right? So you can actually, a simple way to remember this is add sugar to coffee. Okay, add sugar, so you can add sugar to coffee. So add here sugar for sine to coffee. Okay, so this is one way. Of course, there are other ways people to remember this. So this is a slide, I think, helpful when you do the quiz. Okay, quiz is MCQ usually. So this is the 5th slide. Okay, you'll find this inside the notes after I show you where is it. So we are going to look at one example first. Okay, this example, I will send a solution back to you later on when I work out, right? So how do you read the question? So let's read the question first. Okay, given the sine theta is this thing, minus 5 over 13, and then cosine theta is positive without finding the angle theta, right? Find which quadrant the angle is, first part. So remember the angle can be in a first, second, or third, fourth, right? So let's look at where is the angle now. So just now I mentioned that A, S, T, C. So sine theta is negative, okay? Sine theta negative, less than 0. So cannot be in the first quadrant because in the first quadrant sine all is positive. Cannot be a second quadrant because sine theta is negative. So that means the angle must be in the third one or fourth one. Okay, third one tangent positive, fourth one cosine positive. Now sine negative. Now cosine also positive. That means that the angle must be here now. Okay, cosine also positive. So you know the angle. If you want to draw it, this is how it looks like. The angle theta. Y and X now, okay? So Y and X and R, okay? So the theta will look like this. So it's in the fourth quadrant, as I mentioned, because this is first, second, third, and fourth. So the angle is in the fourth quadrant, okay? As I say in the solution, answer there. Okay, now I want to find out what is the value of cosine theta now. Okay, cosine theta. So if you draw the picture of the triangle here, put something like this. Okay, because y is below the x-axis, y is equal to minus y. Because you know that sine theta is y over r. Okay, sine theta by definition is y over r. Now in this case minus 5 over 13. So r is always positive. So that means this is minus 5 here. Y. R is 13. Okay, X is Y. So this is a right angle triangle. You can use a right angle triangle to figure out y and x here because we know that x squared plus y squared equal to r squared. Okay, this is Pythagorean theorem. So x, I don't know what is this. I don't know where is x here. But I know y. Okay, y is minus 5. So the x squared plus minus 5 squared plus r squared. From the r is equal to 13. So x squared is equal to 13 squared is 169. Minus 5 squared is 25. So minus 25. We get 144. So x squared is 144. So x equal to 12. Take the square root of 144 is 12. Because x is positive, right? It's on the right hand side. Since okay, usually we can take square root of plus or minus 12, right? But because x is greater than 0, so x equals 12. So why we need x here? Because then you can find out what is cosine theta. Definition of cosine theta is x over r. Okay, cosine theta is x over r. where x equal to 12, r is 13. So that's why I got cosine theta. And then, how do you find tangent theta now? Tangent theta definition is y over x. Y is equal to minus y. X is 13. So you get this. Sorry, x is not 13, x is 12. Alright, so this answer the part. So this is an example illustrate to you how to actually calculate Trigo function without finding the angle. Okay, so this is an important slide for you, I think, for quick revision. Afterward, I show you where to find this. Okay, so this is actually I let you copy if you have on the copy. So if anything don't understand or find it too fast at the moment, just unmute yourself and then say something, then I can address you. Okay, I think everybody is in the WhatsApp group already. So, and then you can see the slide I put for you. Okay, so next I want to talk about what other application of Trigo you can find. Okay, before you do that, okay, if you go to polymer, the polymer on the first two line under linear source, you can see a revision. This is all about Trigo revision, right? So this is for quiz 1 topic. Okay, for quiz 1 topic, actually in week 2, if you do it, try in week 2. So if you cannot, I think you have, I'm not sure how many attempts you have. Quite a lot, maybe 3 attempts to do this. Okay, so this is for quiz 1 topic. Okay, on the learning mode. Okay, you can get in the learning mode under learning resource. The first 2 topics you will see this. So the information I show you just now were inside this slide here, inside the note there. Okay, so this is also inside the note there. It's actually a revision. A law of sine. Okay, law of sine, what is it all about? Now this is any triangle now. Okay, not just right angle triangle. So there is no right angle there now. So when you label a triangle, usually you have label. So one angle is A. So let's see, one angle is, one angle is B, one angle is C. So let me use different color to highlight to you. I think it's better. So one angle is A, and then the side opposite this is also A, small letter A now. So this is our convention. So this is our convention. And then one angle is B. The side opposite B is small b. And then one angle is C down. The side opposite C is also called C, just small letter C. Use small letter to indicate this. This is how our convention. Okay, so the sine rule say that if I have A over sine A, okay, if you look at this one using this to help you, A over sine A is equal to B over sine B by C over sine C. So this is the called the sine rule. Okay, the side over the angle, or you can turn upside down also can. The same result here. Okay, no matter what you write, as long as you consistently you use one method or two. And okay, so there are a lot of exercise in the revision tutorial. You can try them as much as possible. Hope you try them at home. Because although I didn't ask you to submit, but you should try them at home. Of course, if you have question, you can ask me straight away inside the class. All right. Okay. Then I try to look for the question and then show you. So this is the triangle. Yeah, a lot of practice of this triangle here. Later on, you can see where it's come from. Okay, then there's a law of cosine. So let me draw a triangle again so that I can reference. So you have three angles, A, B, C. And then this B here, this A here, this C here. Okay, so law of cosine say that, okay, suppose I use this one. So I use the A first, and then the B, and then the C. So you say that in order to apply this law of cosine, you can say A squared is equal to B squared plus C squared minus 2BC, right? 2BC cosine A. Okay, A is the yellow one, corresponding side. Okay, this is how you apply the law of cosine. So if you switch the side, then the angle also switch correspondingly. For example, if you want to find B squared, then this one must be now, and the rest is A and C only. If you want C squared, then this one must be C now. The rest are only A and B only. So it's just arrange a formula to get this. Okay, now how about this is for you to find the side, all right? This is for you to find side here. Find side here. How about you want to find the angle? Then you have the rearrangement. Okay, so you can arrange them. Say, okay, move this to the right hand side. You get 2BC cosine A is equal to B squared plus C squared minus A squared. Okay, from this you move 2BC to the left hand side, and then minus A squared. Then from here divide by 2BC. Then you got this angle. So this is for you to find angle. Okay, find angle A. For example, if you find angle B, you always just minus B squared here. So you find angle A, you can find that the angle A here, this is A squared. The rest just change only. You want to find angle B, this is B squared. The rest just you say and see the angle C, this one is C, yes, C squared. Okay, this is law of cosine. So I think this slide is important reference. At the moment, this is like important reference there. So I just pass it to you first. Then, okay, what are the other applications of trigonometry in application? One of them is called the angle of elevation. And at this moment, we will not have sample of this, but next week we will see a sample of this. Angle of elevation is an angle when you look something above the horizontal. So you look up to the object above horizontal. This angle is called angle of elevation. Right? So angle of elevation is used very often because you usually have to look up to find let's say the tower, and then the tower, mountain, all these things to look up here. There is also angle depression. Is look down. Look down, suppose you're flying in the horizontal, and then you look down at an object. That's called angle depression. I have two angles. One of them is look up, you get angle elevation. The other one is angle depression. Okay, this one I think a quick revision. You can find this also in the Trigo quiz. Okay, so this is very, very important now. Something called the true bearing. I think most of you must have come across before. So let's make sure that you all learn. Make sure you learn this. Okay, how to find true bearing? The true bearing is basically tell you direction of a point. For example, let me see in this line, what does it say? Right? Over here, it says the bearing of A from B is 0, 50. Usually when I write true bearing, you have to put a T behind in 0, 50. So what does it mean? That means there are 2 points A and B. Bearing of A from B. That means from B onwards, right? Look up to find A. So this is the B first. B is here. Let's see B here. Look up at the direction 50 degrees. Okay, this is where it comes from. Bearing 50 degrees from B. Then you find A. Okay, look out at this one and you find A. Okay, so therefore, this is how you, when you describe people describe bearing from A from B, it means start from B. Look out the direction 50 degrees from the north, and then you find A. Alright, so remember that when you measure the angle always from clockwise. Okay, clockwise means this way, no? Clockwise, this way. You want to measure angle? Clockwise, all right? Clockwise this way. Where is it? From the north. Okay? I think you all know this, but make sure that you all come across this. Okay? From the north. This is how people find the bearing. Now, how about the bearing from B from A? B from A now. So this is important because this very often used Trigo here. If this angle is 50, then you also know this angle. This angle is also 50. Okay, so you know the one on the 50, then you draw a line join to north, two parallel lines, that this angle was also 50. So how much is this angle now? Where is 250? 230 here, because this angle here is actually straight line is 180. Okay, this is 180 here plus 50. Right? So you know that this is 180, then plus another 50. So this is the bearing of B from A. So this is bearing of B from A. Okay, this is inside your note there. Okay, bearing of B from A. 230, right? So there is certain pattern. So we write this 230, then put a T behind. Okay, so this is bearing question. Now I'm going to show you some example. So inside the note there, example 1. Okay, so we will go through slowly how to do this example. Okay, how to look at this question? Usually you don't need to look at the whole question in general. You just pick out information, one information at a time, otherwise you get too confused. Okay, so let's look at the first information first. port A is 20 nautical miles on a bearing 260 from port B. Okay, this is one information, very crucial information. Port A, 20 nautical miles on a bearing 260 from port B. So there are 2 points, A and B now, port A and port B. Which one is on top of which when you try to draw it? Because the first thing, if you draw the correct triangle, okay, so port A, 20 nautical miles on a bearing 260 from port B. So 260 is actually, if you draw it, so basically the port B there. How come you know B is on top of A? Because from port B you go 260. So you roughly know 260 like this. Because why 260 like this? Because this 0 here, North Pole 0, 0, 90, 180, 270. So 260 is one short 10 degree, right? Because so this is 260. Okay, 260 true bearing. From there you can find A. So somewhere A is somewhere here, so I can draw this one. Somewhere here, this is A. And the distance between 2 ports is 20 nautical miles. Okay, so where are A and B? Which is on top? So you can draw the direction. Say B, B is 260. So it go 260, you have two downward, you get A. So basically, B is on top of A. Okay, so you just if not sure, just draw a few times, then you see where is A now, right? B is on top of A because bearing of A from B is 260. Okay, then next question. At 12 hours, the vessel X steer 50 degrees from port A. Okay, vessel X steer 50 degrees from port A. So if you draw it, so this is North Pole now. You always measure the bearing from the north, 50 degrees. So 50 degrees somewhere here. Okay, this is vessel X here. Okay, so second information. And then vessel Y still at 302 degrees from port B. So again, you have to figure out from port B 302. So where is 302? Maybe I redraw it for you. You can see this. So 302. Where is it? So 302. Let me this one. Where is 302? It's actually near the North Pole, north side. 302, okay, this is 0, 90, 180, 270, and then go back to 360, right? Whole cycle 360. So 302 is actually on upper side here. So that means this direction. So that means what? This angle is 58 degrees. Okay, the 360 minus 302 is 58 degrees. Okay, this is what the three vessel Y move in the direction. Okay, vector y look like this, right? So if you join this, it will be something like this now. This is actually the vector y will move in this way. And these two strips meet each other at the point C, 1 o'clock. Again, they all move at constant speed, so they all move constant speed. So you get this. So let me fill up the information. What this thing is actually this 58 degree here. Okay, 58 degree here. So you construct a triangle. They meet the point. This point they call it C here. So we have 3 points, A, B, and C. Okay, this is important. How you construct them, and let me draw the color code so that you know where I get this information from. This one is a yellow one. I get information from first instance, and green one I get the second information, and the blue one I got it from third information. Okay, basically is this one. So you construct a triangle before I answer the question, right? So this is an important step. We'll solve this problem because we are solving a lot of triangle. So you must make sure that you draw a triangle as accurate as possible. Okay, so are they actually moving at the same speed? Yeah, they actually not the same speed, but actually you can calculate later on the length of the side here. So after I finish the question already, so let's try to figure out the answer. So okay, first I can use the method I mentioned just now. You draw a vertical line parallel North Pole line. Then we know that this angle is 50. Okay, why is it 50? Because the parallel line. So this is 50, therefore this is also 50. Right? Then also you know that because this is 58, so this one is also parallel line. Okay, so this is 58 also. Okay, so get 58 here. So from here, you can find out where is angle C now. Right? Angle C is made up of two angles. One left side is a 50, right side you get 58. So angle C is 58 now. 50 plus 58 get 108. Okay, so you have one side and the angle. What other things you can find? So this is angle C. Can we find another angle because we only have one side so far, one angle now? Let's try to find another angle, right? So I show you that how to find the angle here. So this one is important. So let me show you how the working here. So I WhatsApp to you how to find the angle C. Can we find the angle B? Is there any information you can find angle B? Okay, angle B, let's try another triangle, angle B. So let's try to find angle B now. So angle B, angle C, we know find out is 108 now. Okay, angle B, first of all, we know that this is equal to 10 because this is 10 also. How about this part? We know this is 90 degree, northwest angle is 90 degree. So it's actually, northwest is actually 90 minus 458 here. Okay, plus 10. Okay, so you can find angle B. You can find angle B there is 90 minus 58. Then you get a small angle. 10 plus another 10 degree. Okay, so you can find that this is equal to, calculate here. So calculator, and then find the answer. 90 minus 58 is 32 plus 10, you get 42. So I have two angles now. So one of them is, this is 108. This is 42. All right. So I know angle B from that's how angle C I have using the parallel line. Then angle B I use right angle triangle, because right angle northwest angle is 90 degree, so minus that plus 10. And then how to find angle A now? We know the sum of angle of three angles is 180 for a triangle. Add together is 180. Okay, sum of triangle angle is 180. So you minus 108 minus 42. Okay, then you can find the angle A now. So it's 180 minus 108 minus 42, you get 30. So angle A is 30 now. Okay, so basically you have almost find all the angle except the side you want to find. So this one let's try to solve a triangle. Okay, after you find it, you find out what are the missing part, you know, you can find immediately. Okay, so what the question asks you. Okay, let's go back to the question. What the question asks you here. So we can go back to the question. What it asks you here. Okay, go back for a while. Find the speed of vessel Y. The speed of vessel Y. Okay, so we want to find the speed of vessel Y. So what is the vessel Y? Y is moving in this direction. So this side is the above angle here, A here. So, and then this is actually B here. This is C here now. Label them. Okay. So you can find what is A now. What you find A? A is the distance between A and C. Between B and C, right? Between B and C. Okay. A is distance between B and C. And you'll find that this is actually the speed here. Later on I'll tell you why is the speed here. So how do you find the distance between A and C? So you can use the sine law now, because you can say A over sine A. Okay, sine A over sine angle A equal to C over sine C. Okay, C over sine C, because the side C is 20. Angle C is 108. Okay, this is called sine law. So that means that A is equal to A over sine A and sine 30 degree. A you don't know. So this is actually 20 sine 108. Okay, so that means that rearrange them now. A equal to sine 30 and times 20 over sine 108. So you just rearrange them, you get this, right? So how much is this doing? So let's do a calculation. The 20 times sine 30 and then divided by sine 108. So make sure divided by sine 108 here. So let's see what is this. You get 10.51. Nautical mile. Okay, because our unit is nautical mile. So A is 10.51 nautical miles. But this is the distance between A, B, and C. That is the distance between B and C. How do you tell the speed of the vessel Y? The speed of vessel Y, so you can here, right here, speed of Y is the distance between BC over time. Okay, so distance between BC over time. Distance between BC we find out is 10.51. The time taken, the ship meet at 1 o'clock, right? Actually, the ship starting from 12 o'clock, and then they meet again at 1 o'clock. Okay, so the ship actually meet again beginning at 12, at 1 o'clock they meet again. Okay? So these two ships meet at 1 o'clock. So actually time taken is 1 hour. So 1 hour. So answer is 10.51 knots. Okay, the speed is not now. So 10.51 is the speed of the ship that vessel. Okay, this actually answer the question already, you know. This actually answer the question. So answer is 10.51 knots. Okay, so can you also find the speed of the vessel X? What you need to find? In this case, you have to find out B now, right? B is the distance between A and C. Distance between A and C is B. So you can use a sine law again. Okay, B over sine 42 and 20 over sine 108. You will find B, right? So this is the distance between A and C, and then the speed again is 1 hour, time distance over time. So again, you can find the speed there. So next slide actually tell you, okay? So this is answer. This one no need the question they ask, but you can find this also. Okay, you can find that they actually move at different speed. Okay, the speed are different. So I WhatsApp this to you. Okay, So you can even find the speed of x also. Okay, so I think we have spent, let's look at the last half hour. Okay, this one, another question, another example here. Okay, I think this one is easier one, okay. The ship, you can interpret one statement at a time. The ship travel at 15 degree true bearing from the port A to the place point B. Okay, so this one is very easy. Where is A and B? So B is on top of A now. Okay, so you can quite easy to draw. So I have here. So this is A on the north, 15 degree. 15 degree is quite small, right? So don't need a big angle. So 15 degree. Okay. You take 504 kilometer to get a point B. Okay, from B, the ship then travel 120. So one line at a time. To point C, right? So usually you try to read one information at a time, okay? Unless the question is very lousy, then you read the whole paragraph to this, because we are trying to set question as clear as possible. Otherwise, sometimes the question can be very complicated. Then you have to read whole paragraph, then you get a picture, right? But usually just one information at a time. So now from B, I want to go to C, right? How to go to C now? Okay, draw the bearing again. So the bearing is from B to C, they want 220. So 120 is somewhere here. 0, 90, another 30. So this is 120 now. This bearing is 120. Okay, 0, 90, then another 30 is 120, right? So this is, let's say, go to C now. And then finally, the distance AC is 692. So maybe I have to draw longer one. Okay, let's say C is here now. The distance from A to C is 692. So from here I can join them. Okay, C, yeah. So this is 692. Okay, basically all the information, you have this already. Okay, draw the triangle as accurate as possible. So what they want is find the bearing of C from A. Okay, bearing of C from A. So a bit difficult to tell me now, but let's try to find the angle first, because you only have one side, two sides actually now. Angle is not known yet, right? Let's try to find the angle. Let's see which one is easy to find. Let's say let's try to find angle B first. Okay, angle B is how much? So first thing is angle B, this part is 15, so this part is also 15, right? So 15 here, and then how about this one? You know one whole straight line is 180 degree. So subtract 120, you get 60. So this is how to find angle B. First of all, it's 15 degree first. Then 180 minus 120, because angle of straight line is 180 degree. So it give you 65 degree. Okay, that is so 15 plus 60, 75 degree. So angle B is 75 degree. Right? So I have an angle opposite B. So this one usually is called B here. Yeah? This one is usually called C here. Yeah? Right? B and C. So I can find what now? Okay, let's try, because I think look at the two questions, one of them is bearing of C from A. Bearing of C from A is actually, yeah, I think a bit difficult at the moment. So what looks like what is an easy one? I think you can actually find the okay. I have actually find angle B. B is the easier one. So I want to find, let's say, the angle C. Can I find angle C? Yes, I think so. You can try. First of all, C over sine angle C, okay, is equal to B over sine angle B. Okay, this is one possibility. So we know that C is 504. Angle C we don't know. Then B is 692. Angle B is 75. So we rearrange them, you get eventually the angle C now. So sine C is equal to 504, rearrange them, times sine 75 over 692. So press calculator to find out what is sine C here. So you get 502. Okay, sorry, this is the calculator here. 504 times sine 75 divided by 692, 0.7035. Then how to find C? C is the angle. So what you do is actually to find C, right? To find the angle C here. So what you do is find C, right? I mean right here, yeah. Find C. Use the calculator, right? You have to press the shift, okay? Shift, sine, then answer. Okay, shift sine answer. Let me see. I got this thing after 0.73. Okay, so this one actually. So let me shift sine. Okay, never mind. It's 0.7035, right? I press shift sine. You can sine inverse there. 0.7035. We can press answer also can. Shift sine 0.7035. Then you get 44.7. So that means angle C is 44.7. So this one is 44.7. answer C. Okay, so we take a stop now, but otherwise too many things. So answer C is 44.7. So okay, so how does it going to help you? Help you answer? Okay, so I have 44.7, so you know where's angle A now. So I need to find the angle A. So picture is here. So angle A. So one of them is 75. So angle A. Total angle for angle A, triangle is 180 minus angle B minus angle C, right? Angle B is 75. Angle C is 44.7. And then you can find that this is 60.3. Angle A. So find B first, easy. Then you can use the sine rule to find C. Afterward, you have then use the triangle again. But 180 minus the angle B and C to get A. So how does it answer that question? Okay, from here you can also actually find the question. If you go back, question, I want to find the bearing of C from A. What is the bearing of C from A? So you from A go to C, right? So the bearing from A, this one is this one, right? From the north. So bearing of A from C. So bearing of C from A. From the picture, you can see 115 degrees, because initially there's another 60.3. So 75.3 degree. True bearing. Then true bearing must put a T behind. Okay, this answer the question. Bearing of C from A. Okay, then what is the next question? Is actually distance BC. Okay, distance BC. There are many ways to find distance BC now. You can use, I think, since you know the sine rule. Okay, let me do a simple way to find the BC, right? So I want to find A. Quick one, okay. Sorry. I want to find A here. I use another page here. I don't want to get too messy here. So I try to, so I want triangle. So C, B, A, A. BC is 1, right? So we know that this is 504, this is 692. Okay, and then this one we know is 30 degree. So you know that you can use a lot of things to do. You can take this one for 75. Okay, so maybe you can use this one. So A over sine 30 and 692 over sine 75. Therefore, A is equal to 692 times sine 30 over sine 75. So you press calculator. Okay, so 692, sorry, 692 times sine 30 over sine 75. You get 358. Okay, this is one way. Of course, you can also use another way. Let's say you can use a square equal to b square plus c square minus 2bc cosine a. You can also use this. You find a square, then after take square root also possible. Okay, so this answer the final part of example 2. So I need to mark attendance. So bear with me. Okay, so I WhatsApp the solution to you. Only you can look at the WhatsApp solution. Okay, and next week we'll do some tutorial question. But let me mark attendance first. So I want to share now one. So this one I think I don't want to share this one now. Okay, I mark attendance. See, I can get attendance.
So sorry, sir. For the example 2, right? The answer on the this from Blackboard, it's different.
Answer from backboard. From the backboard means what do you mean? The notes, is it?
Yes.
The notes. What see? What is the notes? Let me back to the.
Sure.
Okay, let me go back to the backboard notes. Okay, so sorry about that.
No problem.
Okay, so okay, I got answer. Okay, example 1, example 2, 622.
Yes.
The answer
622.
is 622.3.
Yeah.
624.3. I mean, what is the mistake I make here? I think I made a mistake.
622.3.
I think the angle is the angle.
I think the answer they round up the figures because our A we're supposed to get 75.3.
Oh, okay.
Yeah.
Let's see what else. A is 30 degree, right? Angle opposite is 30 degree, right? A over sine 30, then 692 over sine 75, right?
Sir, angle A is 60.3.
Yeah,
Oh, I
60.3.
make a wrong mistake, right?
Yeah.
I copy wrongly, right?
Yes.
Yes. That's why the answer is wrong, right? So this is
Yeah.
60. So you make the adjustment. Okay, fine. Thank you.
All right.
So this is 60.3. So this is 60.3. Yeah. Okay. Thank you. So this is 622. Okay. So you double check. Okay, this is not 30 degrees, 33, right? Ready? Let me
So we
check.
cannot see anything, sir.
Huh?
We cannot see what's on your screen.
This one? Okay, sorry. Let me share. I think because I didn't share it. Okay.
Yeah.
So let me share it first. I think this one. Okay, this is one. So you'll find that 60.3.
Yes.
Yes, for angle A.
So angle A is 60.3. Yeah, correct. Angle A is 60.3. So correct. So adjust accordingly. So you should get the answer 62. 62.
Yes.
So this is okay already. So then I can go ahead and mark attendance. Okay.
All right.
Okay, fine. I'm going to mark attendance now. Okay, wait. Iterating because they always ask me My attendant always cannot do this. Okay, so get center, new student schedule, attendance. Okay, I'm doing my attendance now. So let's see. Share. Let's share now. Okay, good. Okay, can you see your name appear there? Muhammad Shafi, are you here?
Yes, sir.
Okay, you unmute speaker
Yeah,
now.
sorry.
Fine.
Yeah.
Okay, fine, good. Marcus Francis, are you here?
Yes, sir. Yes, sir.
Okay. Nafi Kairu.
Present.
Okay. Lee Hong Kiet Eugene.
Yes, sir.
Okay. Nudu Puta Inti Muhammad Sirat. Thank you. Muhammad Zairi.
Yes, sir.
Thank you. Amir.
Yes, sir.
Kankan Amir. Amna. Okay.
Present, sir.
Okay, thank you. Akilan.
Present, sir.
Okay, thank you. Okay, now Muhammad Shah Khani.
Yes, sir.
Thank you. Muhammad Fahan.
Yes, sir.
Muhammad Harifu.
Hafirul, sir.
Hafiru. Okay, sorry. Okay, thank you. Okay. So everybody is here. So I'm on leave or not? No, not supposed on leave. No. Okay. And okay. So I will see you in next lesson. We will try to do some tutorial question. Tutorial 1. Okay. Okay, that will be all for today. Okay, see you in next lesson. Thank you very much.
All right. Thank you very much, sir.
Thank you, sir.
Okay.
Thank you, Master.
Thank you, sir.
Okay, makan. Shit.
Okay, good.
Ah.
Kiwa.
Hey.
Kat dalam tu match group yang